Introduction to Artificial Intelligence by Miomir Aranđelović. Artificial intelligence, or AI, as an attempt to reproduce natural intelligence by human-created system, had a long history, especially in chemistry and medicine. Some of the AI concepts had been present in various old knowledge systems. However, one of the most significant early milestones in AI development happened in the 17th century when Gottfried Leibniz extended the concept of calculating machine to operate on discrete concepts. AI as we know it emerged at mid-20th century through Alan Turing's theory of symbolic computations, using zeros and ones as representations for any real-world objects. Church-Turing thesis suggested that computers can simulate any formal reasoning. While this goal has not been accomplished yet, a prize called Loebner.net Loebner Prize has been given annually to computer program that can talk to people in a way that most clearly resembles the human. Recent years demonstrated fast advancements in artificial intelligence in different areas, such as safe car behaviors, robotics, gameplay, and natural language processing. Computer even won against world chess champion Garry Kasparov. AI development also promises an expanded use in many other areas of human life. Even though the early AI concepts had been developed through the 20th century, the rapid expansion and wide industry use of AI started to happen in the 21st century, when the computer hardware speed reached the levels needed for efficient processing. However, AI is still successful mostly in specialized areas, such as niche information providing, Google search, other search engines, self-driving cars, robotics, computer vision, and gaming. The AI mechanisms are, however, also intensively emerging in other areas, such as autonomous decision-making, algorithm annotations, data generalization, understanding speech and text, machine learning, and assisted communication. Unlike sci-fi views where AI systems think or act as humans, in the computer science, the AI systems think and act based on a specific set of premises and under perpetual and computational limitations. This has been described as a capability of artificial systems to think and act rationally rather than intelligently or human-like. In the cognitive pyramid, DIKW, data, information, knowledge, and wisdom, that existed for a long time, for instance, discussed by Aru in 2007, the artificial intelligence operates on acquired knowledge, information, and data, but it is not completely autonomous, as it is driven by human intelligence or wisdom. Thus, even the AI can be widely applied to different set of problems and provide many solutions. It does not cover the very tip or singularity of the cognitive processing, which joins the rationalization to wisdom. In AI system implementations, each level of cognitive pyramid is associated to a specific system function. Data is mapped to raw system inputs and outputs. Information is mapped to processing and storage of data to various set of databases or other search engines. Knowledge is mapped to information views that make possible different purposes or expert systems, and intelligence is assigned to AI algorithms that include learning and self-adaptation. This cognitive pyramid has existed all time in history, even in old Chinese and Indian philosophy, where they were assigned to 5 elements of human existence, as the top of these elements being spirit, and underneath was metal, reasoning, astral energy, existence, and physical existence. The difference between knowledge and intelligence is one of the key factors in detailing different software functions. Knowledge is the collection of skills and information that was acquired in the system throughout its existence for specific purposes. On the other side, intelligence is the ability to combine and apply various knowledge resources for tasks at hand and to learn from such applications. Thus, knowledge expert systems eventually fade in time as techniques and technologies come and go. However, the intelligence sustains as it functions beyond any technique or technology. At the current state of technology, the main role of AI is used to build intelligent agents. Agents that have physical presence are called robots, and robotics is mostly targeting the robot orientation in physical space. Software agents do not have physical presence and are implemented in software applications such as web crawler, text translation, chess program, or user sentiment analysis system. Both types of physical and of software AI agents interact with corresponding environments. However, robotics requires special layer of adaptation of our application of physical space. The AI agents are constructed to act rationally in their environments, produce the solutions for specific problem or tasks under provided goals and circumstances aligned for such experience. The AI agents need to adapt to specific circumstances, not only in relation to the problem definition, but also to make appropriate choices under perpetual and computational limitations. AI agents are utilized widely for various tasks, but more frequently to assist and support rather than to replace humans. For instance, today they use mostly to perform the computations humans can't do, for entertainment, for instance to produce a realistic gaming environment, at the places where speed or other capabilities robots is required, to assist humans in making decisions by fast access to vast knowledge base, or to take some responsibility over sustainability related tasks such as maintaining temperature in smart houses or labs. Data, information, and knowledge base for AI agent can be specially prepared or deduced for natural environment. Some of the functions that AI agents subsequently perform are pick up necessary knowledge, including information and data, process the knowledge, store the results, based on goals and own capabilities, construct the plan on action, and perform the action in its own environment by the criteria to adapt execution based on the plan. To perform these tasks, AI agents need to represent the world where it operates through multiple representational states, mapped to computational order or environment. The diagram that illustrates AI agent operations is presented in the slide below. For the efficient function of AI agent, the environment model in which it operates needs to be extensible, as general as possible, as close to the problem as possible, and computation friendly. A consequence for the computation friendly environments is that AI world model has to be optimized in the range to be just good enough to cover the problem and neither simple nor more generic. An AI agent should be also able to ensure optional adaptation of accuracy versus computation time trade-off. Some AI problems like the optimal journey of traveling salesman between various locations are very difficult and slow to resolve with full accuracy. However, the usable results can be obtained very fast. One of the other important characteristics of AI models is that they need to ensure a dynamic representation language that is not only rich enough and maintainable, but can enable adaptation of problems in time, incorporating new facts and data during program execution. One of the most frequently used methods to ensure dynamic AI processing to allow updates of constrained data sets required to successful solution is based on constraint satisfaction criteria. Due to such dynamism in AI application execution, it is usually said that these applications operate in exploration mode rather than the exploitation mode characteristic for pre-programmed software applications. To be able to accomplish adaptations to change, AI algorithms are not only subject to test as in other software applications, but also to algorithm training. The success of such trainings are based on the scores that algorithm achieves, similar to the human students. Goal of the training is usually to maximize that score to the high level accurate enough for the successful algorithm application in the field. The AI agents are also able to expand upon its functionality by learning, either guided or learning from the experience executing tasks, to be able to work with perfect information, as in chess, or with probabilistic information, like in poker, and to be able to take either deterministic behavior with a fixed set of input options or stochastic approach with random inputs, based on the nature of the problem. One of the most simple illustrations of AI agent operation could be observed in optical character recognition OCR program. OCR AI agent decomposes the problem into parts by identifying separate characters, which in other applications could be words or other tokens. Subsequently, it approaches the problem iteratively by digitalizing the character area into vectors of zeros and ones that represent the character image. Then it scales the representation based on number of pixels and require computation time. And finally, get taught by simple character fonts with need to estimate similar fonts using the algorithms such as Euclidean distance, which is sum of squares of difference for each element.